if we pretend that capital is always the same, if we pretend the labor is always the same, which means if we pretend that we're always using the same technology, then we cannot explain growth. Study technological change, study TFP, study what, right? Correctly, I don't remember if it was Solo or whoever it was, said that's a measure of our ignorance of technological change. So it was extremely clear that technological change and innovation was the thing. Nobody in the 50s or 60s thought the growth came from capital accumulation. And nobody thought in their best mind that technological change and TFP grew exogenously. In fact, there were various tentatives to adapt it. The vintage model is one example, right? People thought, and I agree with them, that it had to be studied at a micro level because it's mostly a micro issue, how technological change takes place. Okay? So you see, it's not true that there was not awareness of the fact that growth is due mostly to technological change. The old TFP calculations, if you follow Jorgensen and so on, that spent his life doing that, these people are quite aware of that. But in fact, they had to. So let me go to Schumpeter. All of a sudden, you remember I told you at the end I will. So if you read Schumpeter, you know what Schumpeter does. Schumpeter, you should read. You can find it online. The PDF. Download the book Theory of Economic Development. Okay? You know how to spell Schumpeter, right? Yeah, you should be able to find it online. If you don't, let me know. I'll send you a copy. I should have a copy somewhere, a PDF. You don't have to read it all. Just read the first 2-3 chapters. Schumpeter, in words, explained what we did. He says, look, think at a world with a constant technology. A completely stagnant world where there is no innovation, no change, nothing. People just do what we described for a long time. Okay? I believe, he says, it's reasonable from an economic point of view that because in a world like that there is no surprise and taste and commodities pretty much remain the same, if you leave aside wars or natural disaster, there would be a tendency of this war to repeat itself, right? And price to become constant, and this economy may grow slowly at a constant rate. In fact, he uses the word equilibrium in the sense of rest point. It says that economy will have a tendency to go to an equilibrium in the sense of repeating itself. And he also says if we look at reality out there, history, we have seen many economies like that, where basically growth was due to continuous saving of productive resources. You don't eat the cow, you save it. You don't eat all the rice, you save a little bit more, right? And then you accumulate. He says, but empirical evidence shows and intuition shows that in an economy like that, you grow, but you grow very slowly. That's the other important point. But if you look at the history of humanity and you look at periods of relatively constant technology, you see growth, but you also see that it's very slow. Very slow for what we today consider, right? Now we're all 3%, 4%, 12%, right? Instead, when we observe quiet, peaceful society with constant technology, good commerce, we see growth at maybe 0.1% a year or something like that, or even less. Right? So that's Schumpeter observation, which basically is what von Neumann captures with his balanced growth. And then Schumpeter says, but matter of fact, if we look around, we realize that the big burst of growth in human history has always come from technological change. The fact that some people innovated and changed the way things were done. And that changed everything. Changed allocation resources, changed relative price, changed what people did. In certain period, this was a rare event. In some other period, it was a very frequent event. Obviously, he writes this in 1911, so it's published. So it's probably thinking of this in 1905. He's in Austria, Germany. That's the top, it's a very free trade period, high growth. The chemical industry is just developing. It's the second industrial revolution. So he sees a lot of, he's very optimistic in some sense. And so he sees entrepreneurs, blah, blah, blah. So his writings is very much calibrated to the world he's living in, which is the world of Europe at the beginning of the 20th century. But when you abstract from that and you look at what the guy writes, he has an intuition that applies always. It applies, to the Asian countries 500 years before, or 700 years before, or now. It applied to Europe in the 60s. It applies to the States the century before. It applies. Wherever an economy goes through a period of transformation where individuals innovate and change ways of producing, you observe all these big changes in relative price, big shift of factor. Somebody makes a lot of money, and in general, people tend to become better off. Some become a lot better off. And then he goes on describing in his view how it works. I'm not going to get into that. Okay? So why people asked about endogenous growth in the 80s? Let me ask you the question. So in particular, it's unfortunate that, we have the habit of concentrating just one paper as if it becomes successful and so it becomes the only one. But you saw the Solow paper. I have a big admiration of Robert Solow, and I think that that's a beautiful paper. But you know why? You have to read that paper for next week. Just read it. That paper became famous because it's nicely written. But you know what that paper is about? That paper is about a very special case of that model I have given you. Think of that model I've given you in this very special case. Okay? And then where N is exogenous. So what kind of economy is this? It's a very special case of the economy I described, right? Very simple. Labor grows at an exogenous rate. So in an economy like this, if labor is supplied inelastically, there's only one way of getting full employment, right? And it is if KT also grows at the same rate. This is called the natural, that used to be called in those days the natural rate of growth. The rate at which KT grew was called the warranted rate of growth, because KT was supposed to be chosen, right? So workers are growing because mom and pop have sex, basically, and the doctors keep you alive, right? And the laws put you to work. That one instead you choose, all right? In an economy like that, if there is no other equilibrating factor, right, and the level of production is decided in some multiplier form, so yes, that's the level in which factors are employed, but this is determined by some multiplier a la Keynesian, right? Very strange model, it doesn't matter. But that was the model people used at the time. It's known as the Harrod-Domar model. Okay? In that model, you are always on the edge of tragedy. Always on the edge of tragedy. Why? Because if by any chance the warranted rate at which you accumulate is less than N, then you grow an army of unemployed poor people. It's a disaster. So all these people, the mom and dad produce by having sex, and they all go hungry. And they cannot work, because nobody wants them. All right? On the other hand, if by any chance you go crazy and you start investing more at a higher speed than N, you make losses all the time because there is this old idle capital and no workers. Right? So it's a word of capitalist crisis, as they used to say. So if a word is like that, if that's a reason, you see, it's a model. People have to be honest. It's a model. You can write all the models you want. I can write models where elephants fly, where I have 3 ears, and I make, implication of that. Models are models. They're logical exercises. If you want to take them seriously, if you talk about politics or the world, you've got to make sure that what you're assuming is some, Lucas Friedman was very wrong in his naive positivism. I don't care which assumption you make. I only care about conclusion. Prediction, that's nonsense. Like if the model is a way of mimicking aspect of reality, you got to agree that the aspect of reality you're mimicking with your assumption are the relevant ones. So yes, you have to debate assumption. Friedman was completely wrong in his naive epistemology. Because a model is false by definition, and it's purely a way of figuring out what are the logical implications of certain assumption. If you think that you're making prediction about the world, you want to understand the world, you have to discuss the relevance of those assumptions. You have to convince me that those assumptions, that's a very complicated thing. It's rhetorical, it's emotional, if you want, it's ideological, it's a lot of things, empirical. You have to convince me that those features of reality that you are focusing on and you put in the assumption are the important ones. And the other, those you're not focusing on, those you're leaving out of the picture, those you're not assuming, those you're abstracting from, are not relevant for the problem at hand. I don't see any other ways of using model to understand socioeconomic relations. Okay? So obviously one has to ask, the assumption made here, are they relevant? Obviously the assumption made here is that even if workers go unemployed, right, nobody tries to hire them more. And vice versa for capital. Solow said, hey, hold your horses. The market system is crazy, but not that crazy. Because yes, technology in the short run are like that. But he says we can actually change them a bit. When there is an incentive, he doesn't even use Cobb-Douglas. No, he just write down a neoclassical production function, generic. He says, when there is enough incentive, if labor is very abundant, I will try to change technology and use a little bit less capital, more labor. And vice versa, if labor is very scarce and very expensive and capital is very abundant, I will try to do the opposite. And so his point is purely to say, write output like this, he says. And allow for some degree of substitution. He says, if I'm very explicit, let's allow for some degree of substitution. He says, if we allow for some degree of substitution over time, the terrible predictions go away. That's what the paper is about. That's what the paper is about. And he uses a very simple example. There is no maximization utility. He assumes a la Rodoma that people save a constant fraction. We now say, people have log utility, but they save a constant fraction, so consume a constant fraction of income, blah, blah, blah. Okay? That's his point. And you say, why is Baldry mentioning it? Well, I'm mentioning it because if you read the paper, he says, well, so let's study that model. He says, let's assume L grows like you say, and because this is homogeneous degree 1, let me just define xt like this, right? As we always do. And so let's write output per capita in this form, right? He says, well, then they all, he does it in continuous time, but I will do it for you in discrete time, it's the same thing. He says then the whole dynamics here has to do with the behavior of the accumulation equation. If I accumulate a fixed percentage S, then tomorrow's capital labor ratio is this, right? Divided, multiplied by a constant, which is 1 plus n, but forget what I mean. Right? He says, so the equation I want to study is this. Right? It says, what kind of equation is this? Well, I can try to draw, it says, he does it for continuous time again, but for discrete time it's actually simple. I can put xt here, and xt plus 1 here, that's the capital labor ratio tomorrow, right? And in his word, it says, let's consider the case in which 45-degree line, so the capital labor ratio remain the same, all right, over time, so it's very stable. He says there are 3 possible configurations here. The F function, the production function, may be very unproductive. Like before, right? In that case, he says we produce so little we cannot even grow. So the only position here is this. No matter where you start, the economy will implode and will go there. Right? He says that doesn't seem to be the issue. Nobody is concerned about that right now, that we are in such an unproductive situation that we cannot even sustain basic, right? He says, on the other hand, and this is why, the economy may be so productive and capital and labor may be such good substitute that that graph looks like this and never crosses the 45-degree line. In footnote 5 of that paper, you will find him giving a formula for that. He says, for example, the production function f of x could have the form a x plus b square root of x. It's in footnote 5. It's written by Solo in 1955. Before I was born.
Larry Johnson.
Yeah, before I was born. I wasn't born. I born in 56, but the paper was published in 56, so it was written in 55. Right? He says, well, we're not interested in this. This is a very well-known case in which there is enough substitutability between, you see, capital and labor. What's the difference here? Capital is the reproducible factor. Labor is the non-reproducible or exogenous reproducible, which is the same thing, because given that we look at the ratio between K and L, it's the same thing as setting n equals 0 and holding labor constant, right? You understand that? So his point is, we know so well that we put it in a footnote that if the reproducible factor and the non-reproducible one are good substitute, then we can grow forever. Right? In fact, that curve is asymptotic to a curve with slope A larger than 1. Right? He says, but I'm not interested in that because I want to study the Arrow-Domar problem. So I'm going to study this. He says, I want to study that case. The case in which the f function crosses the 45-degree lines, and well, you know exactly what he proves, right? He says, look, it's obvious that in a situation like this, over time, with a bit of substitutability, we either increase the capital labor ratio, decrease it, depending if we start from too much capital, too much labor, and we will not have the Arrow-Domar collapse. That's all. Okay?
You want to put that x star on the 45-degree line.
Oh, sorry, yeah. yes, I screwed up, sorry. yeah. Yeah, thank you. All right? End of class. If we have question, that's what I wanted to show you today. So, accounting, description of activities, very descriptive model, constant return to scale for constant technologies is a logical consequence of a proper description, reproducibility for Neumann, balanced growth, converges to balanced growth, and then the three issues. What does it mean to have income per capita growing? What's human capital? What's technological progress? Ambiguity, right? What's TFP? Again, a measure of technological progress. What did we know since the time of Solos and the 50s about growth? We knew this, what I taught you today. Okay, that's what we knew. In 1960 we knew this. 1970 we knew this. In 1980 we knew this. I got taught it at school, graduate school at Rochester.